Alrighty, so welcome to our first lesson for Seismology 101, and indeed our first lesson for geology. So in today's lesson we're going to be looking at a general overview of the composition and structure of Earth. And the reason why we need to learn this is because at its root, at its fundamental level, all of our geological processes that occur on our Earth are reliant on what happens beneath the Earth. And the way I make this analogous for people to understand is the fact that just like with geography and the need to learn various regions and continents on the Earth's surface, geology also requires an understanding of the regions and zones of Earth's interior. So, my favorite way to show this is via the quarter diagram of Earth. So here we see 1/4 of the Earth. Now obviously this isn't complete, and we'll be completing this for today's lesson. So the very first layer of Earth is what we call the crust. Now the crust starts at 0 kilometers, obviously, and it extends down to about 35 kilometers below sea level. But the thing here to realize is that the crust does change a fair amount. So underneath big mountains and large high plateau fields, this can actually extend down to about 100 kilometers. So the crust isn't just one flat layer, it is a fairly variable layer that changes across. And one thing to keep in mind is that there's more than one type of crust. The first type of crust, which is this high-rising crust up here, is what we call continental crust. Whoops. Continental crust. And the low-rising ones right here are called oceanic. So what the bottom of the oceans are. The bottom of the oceans are oceanic and continental crust. Now our second layer is a very interesting layer indeed. It's the thickest layer of Earth, and if you said it was the mantle, then you were absolutely correct. The mantle is very strange. It's actually split into two different sections. The first section is what we call the upper mantle. And this usually extends from about 35 to 700 kilometers. And what is so fascinating about the upper mantle is that it is pretty similar to the crust. It is brittle and it is hard. We'll talk more about what it's made of later. Now, but the really interesting part of the mantle is by far the lower part. Let me just make this more clear for you. The lower mantle. Now, the lower mantle is enormous. It goes from about 700 kilometers all the way down to about 2,900 kilometers. It's very, very big. And these are all approximate, all these numbers. What you need to get out of this is the relative size. Now, what makes the lower mantle so interesting is that at this depth, this deep beneath the Earth's surface, the temperature is really high and the pressure is also pretty high. But what is so cool about this region is that it isn't hard and it isn't brittle like the rocks above it. In fact, in this region, all the rocks have something called rayed motion. Rayed motion. Okay? Keyword being rayed. Now, rayed is sort of the characteristic of very hard rock, but that flows. And one way that I make this as an analogy is to think about hard putty or very hard Play-Doh. It's solid, but it does flow if you give it time or if you give it enough heat and pressure. And another common rayed object that you may not have heard of, that you see every single day, is glass. Glass is a very common rayed object. And over hundreds and hundreds of years, it actually starts to deform and flow like viscous honey. And so what actually is responsible for our plates moving is actually, in fact, the lower mantle. It is in the lower mantle in which the continental plates up here actually flow. And we'll get into more about plate tectonics later on, but the lower mantle from 700 to 2,900 kilometers displays rayed motion. And this is due to a number of things. The first thing it's due to is partial melting. So partial melting. This is where rocks at this temperature, they don't fully melt, but they do start to liquefy. They start to get molten, you could sort of say. And this is why they float, even though they're still quite hard. But it's also due to a couple of other things, but the most important one is partial melting for this stage. Alright, moving on to our next layer. The next layer is our core, and just like the mantle, it's split into two different sections. The first section is the outer core, and this extends from about 2,900 kilometers, all the way to about 5,100 kilometers-ish. Now, the outer core contains, the core actually, in its entirety contains all metals, okay, all sorts of metals. The most common ones are nickel and iron, iron being by far the most common. But the funny thing is, at this temperature and at this depth, the temperatures are so high that these metals exist in their molten liquid forms. Sorry, I wrote solid there, but it's actually L. They're molten. But as we go even deeper, all the way in to our core, our inner core, from 5,100 kilometers to approximately 6,731 kilometers. Over here, the pressures are so high that even though the temperatures are really high, the molecules of the individual atoms, I should say, of these metals have nowhere to vibrate. So they still exist in their solid forms. Solid. Okay. And so this is our basic overview of our Earth. So let's do a really quick recap. Our first layer is the crust. The crust is very thin. It's pretty much like the skin of a fruit, if we were to compare Earth as a fruit. Now there are two different types of crust. There's the continental crust and there's the oceanic crust. The continental crust is slightly higher, and it is pretty much where every land, terrestrial based living thing lives on. We have our oceanic crust. Now this is the bottom of the sea floor, and it is also very thin. Our next layer is the upper mantle. Now the upper mantle is very brittle and hard, and it pretty much behaves very much in the same way as the crust, though it has a different composition, which we'll learn about later. The next one is the lower mantle. Now the lower mantle displays rayed motion. So the rocks here, they're still solid by all means, but they flow very slowly due to the intense heating and partial melting that occurs in this region. Our next region is the core, which is divided into outer and inner. Our outer, because the temperatures are so high, but the pressures aren't quite as high, nickel and iron are able to exist in their molten liquid forms. Traveling even deeper into the inner core, our iron and our nickel exist in their solid form because pressure is so high, even though the temperatures are also very high. Now we've got to get into the nitty-gritty. There's something very interesting about the crust, upper mantle, and lower mantle. Indeed, that's where most of the action occurs when we're looking about surface processes. So geologists have come up with a sort of classification to help us with explaining plate tectonics and other processes. The first one is the lithosphere. And the lithosphere is the crust with the upper mantle. It's called the lithosphere. Now, just like the crust and upper mantle, it is brittle and rigid. Now, the lower mantle, however, the lower mantle is what we call the asthenosphere. Now, the asthenosphere is quite raised, so it doesn't have as much of the strength of the lithosphere and the crust. Sorry, that's an oxymoron, the crust and the upper mantle. But the asthenosphere is responsible very much for the movement of plate tectonics, of plates, continental motion of plates. That's very important. And throughout our journeys and explorations through geology, we'll be talking frequently about the crust, lithosphere, asthenosphere, upper mantle, and lower mantle. The core, whilst important, does not play a very big part until we get into geophysics, which I'm sure fellow mathematicians watching this video will be very, very happy about. And so this is the structure of the Earth, and this concludes the first part of lesson 1.